Right, tip number 6, this refers specifically to inference questions on the free response section. So whether you're calculating a confidence interval or performing a significance test, we strongly encourage that you follow the 4-step inference process when writing up solutions. So we've made a copy of the 4-step inference plan for both confidence intervals and tests. And this is from our long experience working with the rubrics for scoring these problems. In any significance test rubric, there are going to be 4 elements that the grader is going to be looking for. We've chosen to call them state, plan, do, and conclude. But in the state part, the grader is going to want to see the hypotheses carefully stated. Any of the parameters that are used there need to be correctly labeled. So mu for population mean, p for population proportion. And in some cases, the question will require a definition of the parameter. So the mu or the p has to be carefully explained. Then in the plan step, the expectation is that the inference procedure will be named. So one sample t-test, for example. It's also possible to identify the inference method by giving the formula for that method as part of the calculations. But at some place in the solution, the inference method has to be identified. And also as part of the plan step, the conditions for using that inference procedure need to be clearly identified and checked using the information provided in the problem. So for instance, if you're wanting to do a one-sample t-test, then it's important to check that the data came from a random sample or a randomized experiment of some kind, and also to check the normal large sample condition. So you need to either have normally distributed population or large sample size. In the do step, students can do one of 2 things. They can show the numbers substituted into the formula to get the test statistic, or use the calculator stat test menu to get the test statistic. And the p-value can also be obtained through the stat test menu. So it's absolutely legitimate to write down the test statistic and p-value from the calculator, and any degrees of freedom if those are appropriate for that problem. The advantage to showing the work inside the formula, put the numbers in the formula, is that some partial credit could be available then. If you only use stat test, then it's either an all or nothing proposition if you put information into your calculator and then write down the test statistic and p-value. It's either right or wrong. So to be honest, I encourage my students to use stat tests. I think they're more effective that way. They're more likely to get it correct on a consistent basis, down to occasional typos. And then in the conclude step, we're looking for a clear decision about the null hypothesis. So either reject or fail to reject the null based on the calculations that were done, that clearly links the p-value to a significance level. So hopefully the significance level has been stated at the beginning, and now we're just comparing that p-value to the significance level and making a decision. And then some contextual conclusion that talks about the strength of evidence for the alternative hypothesis. So it's really 2 distinct sentences if my students are writing it. The first one has to do with whether they reject or fail to reject the null hypothesis based on how their p-value compares to their alpha level. And the second sentence is about whether they do or don't have convincing evidence for the alternative hypothesis written in context. The confidence interval side is a little bit easier because there are no hypotheses. So we're just thinking about what we're going to estimate and at what confidence level. So a clear statement of the parameter really helps students get a good contextual conclusion at the end of the problem. The plan step is the same as I mentioned before, and the calculations are the same as I mentioned before. You can use stat tests or stat intervals depending on the calculator to do the do step, but the risk is it's an all or nothing proposition. Again, I want to recommend that writing out the symbolic formula with, for example, x bar plus or minus t star times s over root n is really risky. My students tend to make notation errors, and then the grader has to do, as I said earlier, and do a mandatory deduction. Another suggestion related to this four-step process, because the grading rubrics are set up this way, it makes it easier on the grader if the student labels what they're doing in each of these steps. So something like hypotheses, conditions, calculations, and interpretation, or state, plan, do, conclude, is much appreciated by the grader. It makes it easier for them to match the solution to the grading rubric. And I think quite often students who organize their work in this way tend to perform fairly well. It's a safe bet that at least one pre-response question will require the entire four-step process, and it's possible that there might be a second one on some exams. So I don't have a crystal ball. I don't know what will happen this year, but I'm at least 99% confident that one problem will require a full four-step inference problem. There's a wonderful little inference review at Larry Green's website, Lake Tahoe Community College. So I'm just going to try to launch that link, and then in just a second we're going to be taking some questions. So this is Larry Green's website at Lake Tahoe Community College. It's a wonderful opportunity to practice identifying which is the correct inference method from among all the ones we've studied this year. So from this site, if you click on Select All, and then deselect one-way analysis of variance, and deselect prediction for a single value of y for a fixed x, those are two that we don't really cover in detail or at all in the AP Statistics course. And then once you've chosen your options, you just click Submit. And some kind of research question will come at the top box. So this one's interesting. Do college students listen to the same radio stations as the general public? 2,000 college students were asked what radio station they listened to. Their choices were compared to the known overall rating. So this is a little bit vague, and deliberately so, to have students think about what kind of procedure is being asked for. What I like is it, first of all, forces the decision between a confidence interval and a hypothesis test. So the question is, are we trying to estimate something, or are we trying to test a claim about something? And the wording in the first sentence here seems to suggest testing a claim about whether college students listen to the same radio stations as the general public. That doesn't sound like an estimation question. So I'm thinking test. And then we have to identify what type of test. Is it a test about a mean, a test about a proportion, a test about a difference between two parameters, or possibly a chi-square test that has to do with distribution of categorical variables or relationship between categorical variables. So my reading of this sounds like we're talking about the distribution of a categorical variable, which is radio station preference or primary radio station you listen to, and then we're looking at the distribution of listening preferences among college students. So I'm going to try and guess something here just so you can see the feedback. Oh, good for me. It's always risky when you do one live and cold that you might miss it, but you do get immediate feedback, and if you get it wrong, you actually get a hint to get you back on the right track. So suppose I picked the wrong kind of chi-square test. You see the feedback from me face, and then we can get a little hint here about testing for a distribution, not independent. So good job, we got it right. Okay, at this point, I think we're going to offer up some questions, Nicole.
Great. We do have a lot of questions that came in while you guys were talking, so I will start with those. If anyone has more questions, feel free to send me a message using the chat, not the Q&A. So the first is from Jan A., and it is, can you explain the difference in blocking and stratified sampling? What are the correct definitions?
Okay, this is Josh. Basically, stratified sampling happens when you are selecting a random sample from a population, when your goal is to estimate some characteristic of a population. Blocking happens when you're assigning treatments in an experiment. And that's the key difference is stratified is a technique that you can use when you're doing a sample, and blocking is a technique that you can use when you're assigning treatments in an experiment. They have a lot of the same benefits, and they sound very similar because you start by forming groups that have some characteristic that you think is going to be related to what you're measuring. But again, stratified happens when you're sampling, and blocking happens when you're doing an experiment.